Hello, today we'll look at some examples of solving multiple step equations. All right, so here's our first one. All right, so when solving a multiple step equation, the rules are generally, let me type these out, that I distribute when necessary, of course. Don't always have to distribute, and combine like terms. And my personal preference, not everyone does this, but this is my personal preference. Get variables on one side and then solve as usual. Okay, and that's using order of operations, which is please excuse my dear Aunt Sally, our parentheses, exponents, multiplication, division, addition, and subtraction. All right, so let's do that here. So we have, this time we can actually distribute. So let's go ahead and do that. So I'm going to distribute my 8 through, and I'm going to come over here and I'm going to, oops, that is not what I want to write. 8 times 4 is 32. Minus 8 times 4 is 32. Then I'm just going to bring down what I already have. Right? For me, it's better, and I know for other students too, it's better to go ahead and keep up with your equation as you go. Don't try to do everything in your head, okay? Even as a person who does solving equations all day long, I still like to keep up with my steps. All right, so the next thing, okay, there's no like terms on, and I should say combine like terms on both sides of equations. So for example, I would combine my like terms on the left side and then combine my like terms on the right side. So I can't move these from opposite sides of the equation line, right? I have to combine my like terms with their respective sides. So I can't do that for this one. So now I want to get my variables on one side. So here I have 32K, which really sounds like a lot of money, is over here, and I have negative 5K, which is over here on the right side of my equation. I want them all on one side. So in order to get that, I have a negative 5. The opposite operation would be to add 5K because I need it to go away over here. I don't want it over here anymore, and I want to move it to this side. Okay, so that crosses out and I get 37K. I claim it, minus 32 equals negative 32. Okay, so now this is just like a regular equation that I want to solve using my order of operations. And order of operations says the first thing I want to do is add 32 to both sides. And I get 37K is equal to 0. All right, so I divide both sides by 37. And I get K is equal to 0. No K equal to 0. Okay, so K is equal to 0. I don't think I'll have time to plug in for every one of these, but if I plug it in for here, plugging in 0 is super easy, right? So I just cross that out because I know anything times 0 is 0. Can cross this on out. That's just 0. So 8 times negative 4 is negative 32. So negative 32 equals negative 32. So this is in fact the solution. It works out. All right, so let's do the next one. Again, the first thing I want to do is distribute. So I'll distribute and I get 8 plus 40x plus 5 is equal to 13 plus 5x. All right, so this time I have like terms on one side of my equation. So on my left side, I have an 8 and a 5. These can be combined. So I get 13 plus 40x equals 13 plus 5x. All right. I can already see that this is going to equal 0 again, but we'll go ahead and finish solving it on out. Let me get my variables on one side. I like to move them to the left side. I am kind of biased like that. Either side you move them to, you will get the same answer. So Let's move it to the right side. Let's walk on the y side. Subtract 40 from both sides, 40x. So it grows away. And I get 13 equals 13 minus 35x. All right, so how do I know it's 0? Because I got 13 and 13 on both sides. Crosses out again. I get 0 is equal to negative 35x. Divide both sides by negative 35. Again, I get x is equal to 0. I can plug this in easy again. So I get that crosses out, 8 times 1 is 8. 8 plus 5 is 13. So 13 does equal 13, so it works out. All right, so the next example is an example with fractions. Usually when students see fractions, they get freaked out. Don't get freaked out with fractions. We can work around fractions. We can work with fractions. Fractions are numbers too. So the first thing that I want to do, the first thing that I prefer to do, there's not one way to do this type of problem, but the first thing that I prefer to do is to turn all of my mixed numbers into improper fractions. That's just my preference. All right, so the first one already is in that form. So I got negative 11 over 2. I'm just bringing it on down. And then the next one, negative 2, I'm going to change this negative 2 and 1/3. So I'm going to change that to improper. So that's negative 2 times 3 plus 1, which is negative 7 over 3 plus 3 times 6 plus 1, which is 19 over 6x. The next thing that I like to do, or I like to show my students to do, is to get rid of the fractions. I know I just said there's nothing wrong with fractions. I know I just said it. But we can get rid of them. We don't have to deal with them if we don't want to. So the way you get rid of fractions is you multiply by the least common denominator, or the least common multiple of your denominators. So my denominators that I have here are 2, 3, and 6. And if you remember multiples are those things that I multiply, and I want those the least number, right? So multiples of 2 are 2, 4, 6, 8, and so on, right? And the multiples of 3 are 6, 9, and so on. Multiples of 6 are 12, 18, 24, and so on. Well, the least number that all of these share in common is 6. So if I multiply everything, the entire thing, one big distributive, by 6, my fractions go away. So let's do that. So I have 6 times negative 11 over 2 is equal to 6 times negative 7 over 3 plus 6 times 19 over 6k. You have to multiply everything by the 6, right, to get rid of your fractions. So looking at my crosses, this is just multiplying fractions, normal day in the street. So we have 2 goes into 2 once, 2 goes into 6 3 times. So 3 times negative 11 is negative 33. 3 goes into 3 once, 3 goes into 6 twice. Notice my fractions are going away. That's what I wanted. So that means I did something right. So I get negative 14 plus 6 goes into 6 once, 6 goes into 6 once. So I get 19. Okay. All right. So now this looks like something I can deal with, right? So I'm going to add 14 to both sides. And I get 1 equals, oops, not 1. Negative 19 equals 19. Okay, and I'm going to have to move this over here. I hope that's not a big deal. That's nice and easy, right? Divide both sides by 19. Oh, that's a much prettier number, right? So k is equal to negative 1. So I can plug this back in to see if everything works out. I'm not going to plug it back in here, but I'm going to plug it in here, right? So if I plug in negative 1, I get negative 1 minus 14. Negative 14 minus 19 is negative 33. So it checks out. All right. Woo. Here we go. Another fraction, right? Where we got to do some distributive property. So I know that I just told you, or I just taught you that trick where I multiply by my least common denominator. Before I do that though, I need to go ahead and distribute that 19/6 through. Okay, so that's the first thing that I need to do, distribute that 19/6 through. So let's go ahead and rewrite it. So I get 220 over 3 is equal to 171 over 24r. I'm just multiplying straight across. 19 times 9 is 171. 6 times 4 is 24. Plus 19 times 7 is 133. 6 times 2 is 12. Plus 13 over 4r. All right. So now, least common multiple. I have 3, 12, 12, 3, 24, 12, and 4. 3, 4, 12, and 24. We're all really good at math here, right? We all know that the least common multiple of 3, 4, 12, and 24 is in fact 24. So I'm going to multiply everything by 24, just like I did before. So I have 24 times 220 over 3 equals 24 times 171 over 24r plus 24 times 133 over 12 plus 24 times 13 over 4r. Right? So 3 goes into 3 one time, 3 goes into 24 8 times, and that gives me 1760. I think that's right. Yep, 1760. Sorry about that. 24 goes into 24 once. 24 goes into 24 once. So that's equal to 171r plus 12 goes into 12 once. 12 goes into 24 twice. So that gives me 266 plus 4 goes into 4 once. 4 goes into 24 6 times. 6 times 13 is 78r. All right, so now I have like terms on one side that I need to combine. So I get 1760 equals 249r plus 266. All right. All right, so clearly I ran out of space. So now look at this. It's beautiful, right? I can solve it. So I'm going to subtract 266 from both sides. Crosses out. I get 1494 equals 249r. Next, I want to get my r by itself, so I'm going to divide by 249 on both sides. Now, a lot of people will say, hey, r equals 1494 over 249. Remember, in math, you have to always put in reduced forms, okay? So let's go ahead and reduce it. And guess what it reduces to? That's right, 6. All right, so r equals 6. Am I going to plug this back in here? Absolutely not. You're more than welcome to. Please do. Try it out. See if it works. You can plug it into this one up here, or you can plug it into one of the previous ones that we had. But it should work out. And I hope that this helps.